చూస్తావా దా పెడతారా. Hello, welcome to my lecture series on formal verification with assertions. Today we are going to cover proof, cover, and counter examples, and the tools we are going to use the Jasper board and VC formal as the tools. And the topic is presented by me. So in this, the formal verification, there is an introduction slide. So the formal verification is a mathematical approach to proving the correctness of digital design, unlike simulation, which helps specific scenarios. Formal explores all possible states with the design. It helps catch bugs that simulation might miss, especially in this complex SOCs. So there might be some designs which are very complex. So for that, we can use this one as an exhaustive analysis. So why only formal verification? Because the simulation is powerful, but it sometimes it can miss the corner cases. So for exhaustive checking, it means for every possible input sequence is considered. For that, we will use the formal verification. This is a crucial step as in safety domain, like an automotive, medical, electronics, and a security hardware. Like every bug can save us a more cost, and it will prevent silicon respins. So if something is going to miss, so if you are going to catch that one in the early stages, it will be always beneficial. So why we use assertions in the formal? We use assertions to define the properties. Assertions are written in languages like system verilog assertions or PSL. They come in two types. Like one is the safety properties, another one is the liveness properties. In the safety properties, sometimes there will be bad, should never happen, and sometimes good should eventually happen. In simulation, assertions just check scenarios, but in formal, they become proof obligations. So there is a so for every verification there will be a flow. So for the formal verification also there will be a flow. It's like writing an assertions and run them in the formal tool, and the tools to tries to prove, disprove, or cover the properties. If a property fail, analyze the counter example trace. This flow integrate easily with simulation for the hybrid verification strategy. Proof in the formal. So when the tool proves a property, it guarantees that property holds for a all legal inputs and states. For example, the FIFO will never overflow behind its capacity. This kind of guarantee is impossible with the simulation alone. So in the cover properties in the formal are used to explore reachability. They answer, can this scenario ever happen? For example, can all masters in the bus request simultaneously and still get granted? Covers are excellent for checking design reachability and guiding test bench creation. The bounded model checking. When we go to the bounded model checking, so bounded model checking is a correctness within a finite number of cycles. Say k steps, it's very useful for detecting bugs early in the design. For large state spaces where unbounded proof is too complex, PMC gives a practical way to check important behaviors like reset release sequence. When it comes to the vacuous proof detection, a property might be proven true for the wrong reason. This is called vacuous proof. Example, if an assertion checks a handshake but the handshake never occurs, the property is true but meaninglessly. Formal tools help detect such vacuous proofs so we can refine our assertions. In the counterexample traces, when a property fails, formal tools generate counter-example trace like a waveform showing how the design fails. This is extremely helpful for debugging because it pinpoints the exact sequence that violates the property. We then analyze whether the bug is in the RTL or the assertion. In the The case study of the FIFO correctness. In a FIFO, we can asset properties like no push when the FIFO is full, no pop when the FIFO is empty, data order preserved, first in is first out. Formal ensures these rules are always respected no matter the input sequence. In the case study 2, arbiter correctness. For an arbiter, common properties include at most one grant active at a time. So, no starvation, every requester is eventually granted. Fairness, requests are handled in the right order. And the formal guarantees fairness across all properties request sequence. The advantages of formal with the assertions. Key benefits exhaustive checking, unlike simulation, early bug detection, reducing respins, complements complements simulation by closing coverage gaps. Generate counter examples that speed up debugging. This is why formal is becoming mainstream in industrial flows. Because of the exhaustive bug detection. So, in conclusion, we can say that formal verification with the assertions provide mathematical coincidence, confidence in different in design correctness. With tools like Jasper Gold and VSP, we can handle proofs, bounded model checking, and counter examples effectively. Start small blocks like FIFO or Arbiter and then scale up to like in our next video lectures, we will discuss more about these formal verification methodologies. Thank you. OBS.